previous class we have seen how we calculate the electrical energy in terms of voltage and current, and also we found the equation for power in terms of voltage and current. So today we are going to do two topics. First one is the commercial unit of electrical energy. The first topic which we are going to do is the commercial unit of electrical energy, and then we will see the power rating. So this commercial unit of electrical energy means how the unit in which we prepare electricity bill and all. Okay, so it is a different unit compared to joule. It is not joule, it is in some other unit that we will see today. Then the second topic which we are going to do is the power rating of electrical appliance. That is, each electrical appliance are rated with a certain power. Each appliance will be having a definite power, and the use of this power rating, how useful is the power rating in determining the maximum current through the circuit or appliance, in the amount of energy that we consume, etc. That also will be dealt today. We learned about the definition of electrical energy as well as electrical power, and when we did electrical power, the equation which we wrote for electrical power is W divided by T, where W is the energy or electrical energy divided by the time which is taken. Okay, so that is the definition of electrical power. Now using this equation we are going to find out the commercial unit of electrical energy. So as I told, SI unit of electrical energy is joule, that you know. Okay, now commercial unit of electrical energy is another unit rather than this joule, and it is mainly used for billing purpose, electricity billing purpose. Now let us see how to find out commercial unit of electrical energy and what is actually the commercial unit of electrical energy. So for that, from the definition of power, we can write the equation for electrical energy as power multiplied with time, isn't it? Now you know SI unit. In terms of SI unit, the energy is having unit joule, power is having unit watt, and time, SI unit is second. So you know 1 joule is 1 watt multiplied with 1 second. Now when you are consuming electricity, you know that we are not consuming electricity for seconds. We are consuming electricity for hours. That is, when you look at the consumption of electricity in our daily life, if you are going to calculate how much electricity is consumed maybe for a month, so if you are going with this watt second calculation, so it will be difficult for us to calculate, isn't it? It will be a very big number. So in order to have a convenient method of calculating the electrical energy which is consumed, we are going to have a higher unit or a bigger unit. Okay, so for that what we are going to do is, instead of second we take hour. Okay, because we are consuming electricity for many hours, so it is convenient to express energy in terms of hours rather than in terms of second. So what we are going to do is, power we are going to take it as watt, and then instead of second we take hour. So we have another unit which is watt hour. Okay, so this is the first commercial unit of electrical energy. That is, we can express electrical energy in terms of watt hour, and this watt hour is commercial unit of electrical energy. As I told, we are converting this for the convenience. Okay, because we are using electricity for many hours. So if you calculate the energy in terms of seconds, the energy value will be very large. So it causes inconvenience. So for convenience, we have devised a commercial unit which is watt hour. Okay, now yet another higher unit is there, which is more higher than this watt hour. There what we are going to do is, instead of watt, we take a higher unit of power, that is kilowatt, and hour, which is the higher unit of time, is retained there. So you have another commercial unit which is kilowatt. Okay, so this kilowatt, expressing electrical energy in kilowatt, is more convenient than watt hour. Okay, so here generally we have two commercial units of electrical energy. First one is watt hour and the second one is kilowatt hour. Now let us define this kilowatt hour and watt hour, and we will go to the details. What is 1 kilowatt hour or what is 1 watt hour in detail. So 1 watt hour, it can be abbreviated as 1 Wh. Then 1 kilowatt hour, it can be abbreviated as 1 kWh, where K is represents kilo and W watt, H is hour. Now these two are the commercial units of electrical energy. Now we will see what is 1 watt hour. One watt hour can be defined as it is the electrical energy consumed by an appliance, that is an electrical appliance, of how much power? Of power 1 watt. That is, if you are having an appliance, electrical appliance having 1 watt, and if I am going to use it for 1 hour, okay, when used for 1 hour, there the electricity consumed or electrical energy consumed will be 1 watt hour. So that is the definition of 1 watt hour. It is the electrical energy consumed by an appliance of power 1 watt when it is used for 1 hour. So similarly we can define 1 kilowatt hour also. The only difference is, when you are defining 1 kilowatt hour, the same definition can be used. Only difference is, when we write or when we say about power, instead of 1 watt you have to write as 1 kilowatt. That is the only difference. So how will you define 1 kilowatt hour? 1 kilowatt hour can be defined as, it is the electrical energy consumed by an appliance of power, how much? 1 kilowatt when it is used for 1 hour. So that electrical energy is written as 1 kilowatt hour. So that is about 1 kilowatt hour and 1 watt hour. Now this kilowatt hour, that is the bigger unit or commercial unit of electrical energy, 1 kilowatt hour, it is also known as another, it is usually represented using another term, that is 1 unit. Okay, that is when we get electricity bill and all, we say we have consumed 100 units of electrical energy. Okay, or maybe we used 150 units of electrical energy. So there, this unit actually represent what? This 1 kilowatt hour. So 1 kilowatt hour is known as 1 unit. And this we don't say 1 kilowatt hour of electricity consumed, or when we are having the bill inside the electricity bill, they don't write kilo in terms of kilowatt hour, they simply write it as unit. Okay, so it is understood that 1 unit is 1 kilowatt hour. So 100 unit means 100 kilowatt hour. That much energy is consumed in 1 month. Okay, so that is about the commercial unit of electrical energy. Now let us see how we can relate this commercial unit with that of this SI unit. Okay, so 1 watt hour can be converted to SI unit. It is very simple. 1 watt will be 1 watt itself, because SI unit is also 1 watt, and hour you convert it into second because SI unit is second. So 60 multiplied with 60 second. Okay, so 1 watt hour, that is equal to, you got 36 and 2 zeros are there, watt second. You know this watt second is joule. So you have 1 watt hour is equal to 3600 joule. Similarly, we can convert 1 kilowatt also. 1 kilowatt hour is equal to, so kilowatt should be converted to what? Watt. So 1000 watt, then hour to second. 60 multiplied with 60 second. So you got 36, 2 zeros are there, then 3 zeros of kilo. That much watt second. Watt second is joule. So you got 1 kilowatt hour is equal to, can convert this in terms of power of 10, 3.6 multiplied with 10 raised to 6 joule. So this is the relationship between kilowatt hour and SI unit joule. So we can convert commercial unit to SI unit as well as SI unit to commercial unit using this relationship. Next, let us see about power rating of electrical appliances. Here I have shown a filament bulb, which is also known as incandescent lamp. So this, here you can see the filament of the bulb. That is when electricity passes through the filament of the bulb, the tungsten filament, when it is heated up, it will glow and we will get light. Okay, now if you look at the surface of the bulb, that is on top of the bulb here, you could see something written over there. Since this is a very old bulb, the writings are gone, so I have written here whatever is written on the bulb usually. Okay, so you could see 60 watt and 220 to 240 volt. So you can understand that this 60 watt means it is the power, okay, power consumed by the bulb, and this 220 to 240 volt, that is actually the voltage which is needed for the working of the bulb. Okay, so actually this 220 to 240 means if we consider different regions or different country, this voltage which is being supplied during the power transmission will be different. For India it is generally 230 volt. So if it is written 220 to 240 volt, actually the device can work under these voltage range, ranging from 220 to 240 volt. Okay, and 6 watt means the power which the bulb consumes during its working, that is 60 watt. So the writing which we see on the electrical device indicating the power consumed by the device and the voltage under which it works, it is actually the power rating of the electrical device. Actually, from the power rating of a electrical device, we can find out how much maximum current or safe current which can flow through the device. That is, if more current is flowing through the device may get damaged. So you can calculate the maximum or safe current which can flow through the device using this power rating description, and also you can even find the value of resistance while the device is used. Okay, when the bulb is glowing, how much resistance will be there for this filament. So that also can be calculated using this power rating description. So this power rating is not only for this bulb, it is it can be seen on any of the electrical appliances that we use. Okay, if you see or if you examine the any electrical appliance, you could see a sticker which shows these writings, that is
the power will be written, the voltage will be written, and some other electrical or details will be written on that sticker. Okay, so now let us see the case of other devices also. Taking the case of microwave. So there, backside of the microwave, if you watch, you can see a sticker like this. There also you can see the volt written as 230 volt there. Then the microwave power, it is written as 1200 watt. If you are using it in the grill mode, convection mode, different power, more power is used when we are using it in the convection mode and all. Okay, so any device, if you see, you could see that there will be a rating which shows power and voltage. Okay, now if it is an AC, there also at the side of the AC you could see one sticker that shows the description of the power supply, the power at which it is working and all. See, the input power, it is written as 1011, that is 1 kilowatt, almost 1 kilowatt. Okay, now the voltage is written, see, 230 volt. That means here we can use that AC 230 volt. It functions in India. Now if you take the case of an electric iron, so there also see, here you can see a sticker. There you could see 1000 watt. So the power consumed by electric iron is 1000 watt or 1 kilo watt, and see the voltage at which it works, 230 volt AC, 50 hertz. 50 hertz is the frequency of AC which is being provided in India. Now if you take another electrical appliance, for example electric kettle, there also maybe somewhere on the electric kettle there'll be a sticker which shows this rating. That is, here you could see 600 watt, that is the power of under which the kettle works, and 230 volt. So the voltage which is needed for the working of this kettle. So for any electrical appliance, if you see, you could see the rating written on that, which gives the power as well as the voltage at which the appliance work. Now let us see what is the use of this power rating, or what is the use of these information given for the electrical appliances, or what all things we can find out, or we can conclude from these informations. So as we said, two things are written on the appliance. One is the power and the other one is the voltage. Power and voltage. Okay, now we know the relationship between power and voltage in terms of current, resistance and all, isn't it? You know that power is equal to voltage multiplied with current. Okay, that is one form. Then also you have another equation for power as V squared R, where R is the resistance of the appliance. Then there is also another equation V squared by R upon R. Okay, and another equation is I squared R. So three relations are there for power. Power is voltage multiplied with current, or V squared by R, and power, it can also be written as I squared R. Okay, so as I told, in power rating we have these two informations, that is power is written on the device and the voltage is also written on the device. So if you know power and voltage of a device, that is the power which is needed for the working of the device, and voltage under which the device is working, then we can easily find out the value of current, okay, maximum current that can flow through the device, as well as you can find out the value of resistance of the device when it is working. Okay, that is if you want to find the current, okay, the equation will be power divided by voltage. If you want to find the value of resistance, the equation will be V squared upon power, voltage square upon power, isn't it? So suppose you want to know how much resistance is offered by the device while it is working, you just have to take the square of voltage and divide it with the power given on the device. Okay, now if you want to find the safe current, okay, so this is actually the safe current. Safe current means the maximum current that the device can hold. So if more current is passing through the device, maybe it is not good for the device. Okay, the device may get damaged. So there is a safe current that can flow through the device while it is working. So it can be found out using this equation, power divided by voltage. Now let us take the examples which we have. Let us take the example of this incandescent bulb. So here we already saw that the power is 60 watt and the voltage, normally the voltage maybe 220 or 230. So I am going to take the voltage which is being supplied for this bulb is 230. So if you want to find the safe current which can pass through this bulb, you can use the formula, that is power divided by voltage. So here power is 60 and voltage is 230. So if you divide and see, the you'll get the value of current to be 0.026 approximately. I am writing only approximate value, 0.26 ampere. That means maximum or the safe current which can flow through this filament is 0.26. If more current is passing through the filament, then the filament will melt and it will break. Okay, so maximum 0.26 ampere current can flow through the lamp. So if so you know that if voltage is increased, current will also increase. So suppose the voltage supplied is increased beyond a limit, then what will happen? The filament will heated up more, current will pass, more current will pass through the filament, it will get heated up and it will blow off. Okay, so if you know the maximum current which can flow through the device, so you have to maintain that current, so for the safety of the device. Now suppose we need to find the resistance of the filament while it is working. So you can even find out that using the formula. You know power is equal to V squared divided by R. So therefore resistance R is equal to V squared divided by power. So here 230 square divided by 60. So if you find the value of 230 square divided by 60, you will get 881 ohm, almost equal to 881 ohm. So this will be the resistance of the filament while it is being working. So when it is glowing, the resistance of the filament will be 881 ohm, but when it is not working, the resistance will vary, because while it is glowing, you know that resistance depends upon the temperature of the filament. So while it is not working, the resistance will vary. This is the resistance of the filament while the bulb is glowing. So thus we can find out the safe current flowing through the bulb as well as the resistance of the bulb while it is working or glowing from the power rating description. Okay, now let us see another device. Let us take the case of this. We'll take the case of this iron box. Okay, so you can see that different appliances will be consuming different power. For example, microwave. So it is a highly power consuming appliance. You could see that almost 1200 watt, that means almost 1 kilowatt power is consumed. So that means more power is consumed. So if a microwave is working for 1 hour, okay, how much energy is being utilized? Energy will be 1 kilowatt hour. That means 1 unit of energy will be consumed. Suppose we are using that microwave for 1 hour. So it is a power consuming device. Similarly, for the case of AC, you can see that this is also consuming more power, almost 1 kilowatt. Okay, so that means 1 kilowatt means 1000 watt. So if AC is working for 1 hour, you can see that the energy consumed will be 1 kilowatt hour or 1 unit. That means if you use AC for 1 hour, 1 unit of energy, almost 1 unit of energy will be used. So suppose you are using AC for 10 hours, 10 units is being consumed. So you can imagine how much energy is used by AC if you are using AC throughout the day or maybe for long hours. So it is a power consuming device. Okay, now iron box is also they also utilize a large amount of power. Here also you could see that power is 1000 watt. Okay, so there 1000 power is 1000 watt, and in India I told we consume 230 volt. So there, if I need to find the maximum current or safe current, okay, what should I do? Power divided by voltage, that is 1000 divided by 230. So if you do the calculation, 1000 divided by 230, you will get the answer as 4.347 ampere. So this is the safe current which can be which is flowing through the electric iron, while it is in use. Okay, now similarly, using the other equation, that is resistance is equal to V squared by P, we can find out the resistance of the electric iron when it is being used. Okay, so this is how we calculate the resistance of the device and the safe current that can flow through the circuit. Okay, so the importance of power rating is, if you know the power rating, you can actually calculate how much maximum current or how much safe current can flow through a device. Okay, if more current is passing through the device, then of course the device may get damaged. So you can understand about, or you know about the safe current which can flow through a device by means of this power rating. At the same time, you can calculate the resistance of the device when the device is being used. Okay, so that is about power rating. And also seeing the power, that is when we see the power, you will get an idea of how much energy will be consumed by that device, so that by wisely using those devices we can even reduce our electricity bill. Okay, so if you know the power, you can actually estimate how much electrical energy will be consumed. Suppose I am using microwave for maybe half an hour a day. Okay, so if you know the power, then you can easily calculate the energy for 1 month. So you can estimate how much of units of energy, how much unit of energy is consumed by microwave in 1 month. Okay, thereby you can even calculate how much money you spent while you are using microwave for 1 month. So all these things can be actually determined if you know an idea about the power rating of electrical devices.